All right, lesson 98. We've got distance between 2 points and slope. I kind of wish that Saxon would not combine these two things because then sometimes kids get confused which is which. So try to remind yourself which is distance, which is slope. They're totally different things, okay? And you will do this again in Algebra 2, okay? So first we have use the Pythagorean theorem to find the distance between 4, 2 and -3, -2. All right, so Pythagorean theorem can tell us the distance between these points. So just make a little graph real quick, and we'll plot the point 4, 2. And we'll plot the point -3, -2. And we want the distance between these 2 points. Okay, so how far is it from -3, -2 to 4, 2? Okay, distance between 2 points. We just learned Pythagorean theorem the other day, right? So you could make this into a right triangle. And really, you could draw this right triangle above or below the line, okay? I'm going to just draw it above. So you have to go up, and you have to go straight up, and you have to go straight across, okay? So what I could do is look at this distance between the y's. So if you don't have a great graph, because most of you guys don't have graph paper, it's hard to tell exactly how far that is. Whereas my grid, I could count pretty easily. However, if I look at the distance between the y's, because this is the rise, right? How much is that distance? Yeah, it's 4. All right, and then I want to know how far is it along the x's? How far between the x's? What's the distance? 7. Okay, and then I can easily find a squared plus b squared equals c squared, okay? So now I can do Pythagorean theorem to find the distance. It's always that c side, okay, between the 2 points. So 4 squared is 16, 7 squared is 49. Okay, add those, and that would be 65. Okay, and then we got a square root 65. And we would just leave it as the square root of 65 because, what is that, 5 times something? I don't know. It's not a nice one, though. Doesn't simplify, okay? All right. Now, there is an actual distance formula, so you don't have to always do Pythagorean theorem. I actually recommend that you learn the distance formula and use it instead of Pythagorean theorem, okay? It is the exact same thing. It's just shortening it up a little bit, okay? Let me show you. So the distance between 2 points is always going to be the y minus the y squared. Okay, I always do like the second y minus the first y squared plus the x minus the x squared. This is exactly what I just did, okay? And then you square root it. So this comes from the Pythagorean theorem, but it's called the distance formula, and it's what you want to use. So what I did is I did the y minus the y. -2 minus -2. So if I were to plug this in, okay, I would do -2 minus 2 squared. Yes, it is going to be a -4, but you're going to square the negative out because it's a distance. So I am going to get that 16 that we got from above, right? Okay, then I'm going to do the x minus the x. So the second x is -3 minus the first x. So this would be -3 minus 4 squared, which is -7, but we're going to square the negative out to get that 49 that you got from above, okay? And it'll give you that same answer. Okay, find the distance between -4, 3 and -2, 5. And actually don't do slope yet, okay? Just distance. And I actually don't want you to graph this one, okay? I want you to learn to use the distance formula because that's what they're going to ask for mostly in Algebra 2, okay? So I want the distance between the 2 points. So my formula is the square root of the second y minus the first y squared plus the second x minus the first x squared. Okay, so I am going to do distance equals the square root of. What is the second y? Yes, so don't forget these are all x, y coordinates like always, okay? So it's 5 minus 3 squared. Okay, so I'm doing the second y minus the first y, plus, what's the second x? Okay, and then you guys, there's a minus in the formula, and we're subtracting a negative 4. Yes, so that will become positive. All right, so now I have distance equals 5 minus 3 is 2. Whoops. Okay, 2 squared plus, this turns into a plus, okay, so negative 2 plus 4, because it was minus a negative, so that would also be 2 squared. All right, then you have to square them both, so 2 squared is 4, and the other 2 squared is 4. Then you have to add them both, which is 8. And then at the very end, we square root. Can you square root these 4s right here? No, you cannot, okay? You have to do everything under the square root first, and you have to square root last, okay? So this is 4 times 2, and the square root of 4 is 2, and the other root 2 stays inside, okay? And we're finding there the distance between the 2 points, as if you did make a triangle and find the distance between the 2 points, okay? All right, let's now find the slope. Totally different concept. So again, I don't like that they combine these together, but they do it all the time, all right, in Saxon. So the slope between 2 points, remember y equals mx plus b, where we graphed lines, okay? Just m is the slope. It's how tilted the line is. That's really what the slope is. What is the tilt? Positive or negative? Is it really steep? Is it less steep? Okay, so write it down like this. M equals, this little triangle means delta y, or change in y, over the change in x. So we do y2 minus y1 over x2 minus x1. Okay, and that will tell us how tilted the slope is. The rise over the run. Okay, so let's find the slope between 1, 2, and 5, 6. Okay, so we do y2 minus y1 over x2 minus x1. And you guys, this is on the SAT all the time. Okay, I just did the slope like 3 times with the SAT kids the other day. A lot of Algebra 1 and Algebra 2 is on the SAT. Okay, so what is the second y, everyone? 6. What's the first y? What's the second x? Minus the first x? Good. So 6 minus 2 is 4, and 5 minus 1 is 4. So my slope is 1. Okay, this actually means that, I don't know where the y-intercept is, you guys, but you're going 1 over 1 for the slope, right? Like if you were to graph it. Okay, and that's it. Find the slope of the line that passes through 4, 7, and negative 14, negative 12. So m equals y2 minus y1 over x2 minus x1. What's the second y? Okay, minus, what's the first y? Okay, over, what's the second x? Minus, what's the first x? Okay, so this would be negative 19 over negative 18. And what is a negative over a negative? Yeah, so switch it to positive. Always leave these as an improper fraction. Don't write 1 and 1/18, because like we would graph this like 19 over 18. Okay. There's a few weird ones on here that I have to do, so let's do these real quick. Okay, let's find the slope yet again. What is the second y? What's the first y? Okay, good. So on the top, I have 3 minus 3. These are some special cases, okay? So you might want to write these down, even if you're like, that's really easy. But write these down because they're weird, okay? Over, now I do the x over the x. What's the second x? What's the first x? So minus 2. So I get 0 over negative 6, okay? What does 0 over negative 6 equal? What does a slope of 0 look like? It is a line. Yes, it's one of the special ones. So actually, if you plotted these points, 2, 3, negative 4, 3, what kind of line is this? Yep. This is a slope of 0. Is this an x or a y graph? It cuts through the y-axis at 3. So it is a y graph. Every single y graph has a slope of 0, okay? Because it cuts through the y-axis and it's flat. It has no tilt, okay? Notice I can walk on the ground, 0 slope, okay? Not going uphill or downhill, all right? Now let's try another one. I don't think this is a special case one. We don't need to do this one, but we do need to do this. This is the other one that's special, and then we'll be done, okay? So again, m equals y2 minus y1 over x2 minus x1. All right, what's the second y? What's the first y? What's the second x? Okay, and we have minus the first x is 2. Okay, so we get 2 over 0. Uh-oh. Can we have 0 in the denominator? No. You have to memorize this lovely word, okay? The slope is undefined. Okay, it is undefined when you have 0 in the denominator. Just making sure I'm not missing anything. Okay, so if you plot these points, right, I have the point 2, 5, and I have the point 2, 7. Okay, what does this line look like? Yeah, it looks like this. X equals 2. Okay, every x graph, every single x graph has an undefined slope. How I remember this is you cannot walk up a wall, right? So here's the line that goes up. Can't walk up a wall, but this one is a slope of 0. Okay, my flat one is 0. Otherwise, undefined. All right, you guys, let's try a few of these.